Okay, hello class. Welcome to lesson 5 on transformations of base functions. So in this lesson we're going to be looking at transforming some of the base functions we just saw in the last lesson. And so we're going to need a little bit of function notation just to talk about these functions generally. So if we had any function, in this case we have the absolute value one, if we wrote it like this or thought about the input being subtracted 3, using function notation we could sub in x minus 3 into the right side as well. And what we'd actually be graphing is the absolute value of x minus 3. So that's what that actually looks like. B is similar. It's like we're going to be doubling all the outputs. And so we could take the absolute value function and multiply it by 2. C is similar. We can add 3 to all the outputs. So take the absolute value function and add 3. And in D, what we're doing is tripling all the inputs. And so what the function is the absolute value of 3x. And so these are actually the graphs, the functions that we would graph. So we'd graph like y equals absolute value of x minus 3. The goal is to start looking at transformations, connecting different representations of functions, and how they're similar to different things. And so we'll see that through the parameters a, k, d, and c, and how they have a effect on different base functions. We'll call those f of x. And can you describe those effects in terms of transformation? So actually what's happening. So we're going to be doing this in Desmos, and so this form, although we'll only look at one of these parameters at a time, so it'll look a lot simpler. But for this video, I'm going to go very quickly through the Desmos part. I'm going to just more talk about the summary of what happens when we sub these numbers in. So just looking at the one on the outside, the add c, it would look like this for the function add 5. And so if we take all these functions, we could add 5 to them all, or take all these functions and subtract 5 from them all. And so we see what the functions actually look like. If we looked in Desmos, we could see, like, if we had absolute value of x, which looks like this, I'll just go into projector mode so you can see it better. And if we said, okay, well, what if we add 5 to the outside? You can see what actually happens. And if we said, okay, well, let's add a variable and change that. And so say if we add 1, it looks like this. If we add nothing, it would look like this. You can see clearly that the shape's not changing, and we're just shifting that function up or down. If we change that function to the 1 over x function, so this is the 1 over x function, and if you had like plus 5, you can still see that shifting up or down, and it's that horizontal asymptote that's changing up and down. So you can clearly see if like you had plus 5, it would look something like that. If you had nothing, like plus 0, just the regular function, it would look like that. And then if you shifted it down, it would look like that. And each one of the functions, that's what the parameter does. I should have called it C, but it doesn't really matter. Okay. So what's happening here is, like, we just really have a vertical shift value. And if it's bigger than 0, it shifts up. If it's less than 0, it shifts down. When you have when you're subtracting from the inputs, what happens is, like, the inputs all change inside the function, or we add 2 to the input. We can see, like, from Desmos, if that number is on the inside, so say we have plus 2, what's actually happened is it's been shifted to the left too. If you do minus 2, it's shifted to the right. And if you did this as like x squared, and so you probably recognize it from quadratics in grade 10. Just want to make sure we put brackets around this. So we'd say x minus 2, and then square that. You can see that shifted to the right 2, and if you add x minus 10, that'd be shifted to the right 10. And so then plus 3 would shift it to the left. And so in this case, it shifts it left and right. So if we did minus d and add slider, it shifts it to the right when it's minus a number. So this is like minus 7, minus 8. And it shifts it to the left when it's plus a number. So this is like a minus minus, which would really show up as a plus in the equation. And so in terms of like transformations, these guys, if you graph them, they shift left or right. Now, one thing to notice, like kind of the reason why they're shifting opposite, like you want to realize that since you're subtracting 4 from the inputs or adding 2, um, like for the first one, for this line here, we want the inputs to actually be 4 larger, because you can imagine like if you subbed in 0, really you're not subbing in 0, you're subbing in -4 to square. So like instead of subbing in like your key points at -2 to 2, you probably want to sub in things like um, +2, +3, +4, +5, +6, because you're going to be subtracting 2. So you actually want them bigger to start with so that you get those same y values as the base function. Because what we're doing is, like when we say shift to the right 4, we're saying compared to y equals x squared, we're shifting it to the right 4. We're shifting this guy to the right 4. And so you don't want to sub in 0 here, because you can't do that. You actually want to sub in 4. And the square root graph's a good one to see that. So if d is greater than 0, you're shifting it right. So if you had x minus 4, and the general form has the minus, but so if you see like a plus or a -4 here, it's right, and a +2 would be left. You don't have to worry so much about the fact that it says minus d. You just, when you see it, you realize that this is left 2 and this is right 4.